What is boiling point? Boiling point is that value of temperature at which the vapor pressure of the liquid surface reaches the value of pressure of the surroundings. By increasing the temperature, we are actually increasing the vapor pressure of the liquid, and when it becomes equal to the ambient pressure, boiling will take place. Greater the value of ambient pressure, greater will be the boiling point of the liquid. The pressure of the liquid is increased with the help of temperature. Raising the temperature increases the value of pressure. The temperature at which the pressure of the liquid reaches the value of ambient pressure is termed as boiling point of that mixture or substance. What is boiling point of surface area? The correct interpretation of this question is, what is the effect of surface area on the boiling point of the mixture? We all must have known by now the effects of temperature and pressure on the boiling point. When the surface area of the molecule is taken into consideration, we first start revising the concept of van der Waals force first. When the carbon chain gets longer, the van der Waals force gets stronger and hold the atoms tightly, hence the boiling point for longer chain is more. When branching takes place, the value of boiling point decreases due to reduction in attractive forces and increase in repulsive forces. So it becomes easier to break the bonds. Relation between boiling point and surface area. The relation between boiling point and surface area is already discussed in the above section. The boiling point increases as the surface area of the molecular compound increases. This means that when the number of carbon increase in a linear chain, the boiling point also increases with it. When branching takes place in the compound, it is then the boiling point reduces. The increase in boiling point due to surface area happens due to increased attractive forces between the atoms. Does boiling point increase with surface area? We have already discussed this in above sections, that the boiling point of the compound will increase if the chain has more carbon atoms attached in a linear fashion. It is important to note that the boiling point will increase only if the carbon atoms are arranged in a linear fashion. If the branching takes place, then the boiling point will decrease as the van der Waals force of attraction reduces. It becomes easier to break the bonds. Does molecules with more surface area increase boiling point? The surface area of the molecule depends on the amount of van der Waals force acting between the molecules. The force of attraction increases with the increase in surface area. Due to strong attractive forces, the boiling becomes difficult. If the carbon atoms make a compound using branches, then it might have a lower boiling point because the molecule gets crowded and repulsive forces become significant and more dominant. Hence we can say that increase in surface area of the molecule increases the boiling point of the compound. Factors affecting boiling point of a compound. When we consider the macroscopic factors that affect boiling point, we know that the ambient pressure decided the boiling point of the substance. But when we consider the microscopic level or molecular level, there are many factors that come into play for deciding the boiling point of the substance or compound. The factors affecting boiling point at microscopic level are given in the section given below. Intermolecular forces. If the intermolecular forces are strong, it gets very difficult to break the bonds between them. So the process of boiling takes more efforts. The molecules can have many types of bonds that bind the two atoms together. These bonds are ionic bond, hydrogen bond, dipole-dipole, and van der Waals forces. The forces are mentioned in the descending order of their strength, which implies ionic bond is the strongest and van der Waals force is the weakest. Molecular weight. The tendency to get polarized increases as the molecule becomes heavier. More the tendency to be polarized, more will be the efforts required to boil the substance. This is because the attractive forces increases as the element becomes more and more polar. Shape. When the compound has a long chain of atoms, then the surface area will be more and hence the van der Waals forces of attraction. Due to these forces, it becomes difficult for the bonds to break. Hence the boiling point also increases. When branching takes place, the surface area decreases and the van der Waals forces decrease. So the boiling point also decreases. What happens when the surface area of compound increases? As discussed in the earlier sections, boiling point of the compound will increase as the forces of attraction dominate. Due to high attractive forces, the efforts required to break the bonds increases. Hence it takes a higher temperature to break these bonds and convert the liquid into its gaseous state. Hence carbon compounds having long chains have a greater boiling point. The reason being that they have strong attractive forces. When branching takes place, the long chain becomes shorter and hence the attractive forces become weaker. Due to this reason, the boiling point of the compound decreases significantly. From above discussion we can conclude that boiling point increases with increase in surface area and decreases with decrease in surface area. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.